करें. And today will be our second last class. One more class is required for moving coil galvanometer. That we will have tomorrow or day after tomorrow, no problem. Left hand rule, nothing is there in that, Akash. That is class 9, 10th standard thing, no problem. Yeah. So shall we start with the class? Yeah, hard work going on, no problem, no problem. Second last class. Okay, Manas, revision will be there, I will be there, don't worry. Before sending you, before kicking out you to the NEET college, to the medical college, we will not end the class. No problem, type of class may be ending, but my class will not end. Till the day I will not kick you out of the go slides to the medical college. Class will continue. No problem. Yeah. Okay. So I think in last class we were talking about magnetic field due to long straight wire. We studied circular wire. We studied then circular arc. We studied these three applications done in the last class. Bol do bhai. Now we'll start with the class. Bolo bolo bhai jaldi twarga samay hum le do. We talked about long straight wire, then circular wire, then circular arc. All these things we studied. Three application, three value of magnetic field we did in the last class. Three more values are there which you have to remember, which will be asked in our NEET exam, which are very, very important. No problem. Circular arc done, circular coil done, straight wire done. So now we will talk about three applications done. Now we'll talk about fourth one. You can write magnetic field due to solenoid. Magnetic field due to solenoid. Magnetic field due to solenoid. So we will talk about magnetic field due to solenoid. Again, important part, direct questions are asked. Direct question means if you remember the value, you will get marks in the exam. If you don't remember, you will not be able to do the numerical. Yeah. So we are going to talk about magnetic field due to solenoid. And I think everyone has seen solenoid. You have seen solenoid previously also. Or in EMI chapter also you have seen the solenoid. So we are going to talk about magnetic field due to that solenoid. No problem, no problem. So see here, yeah, okay. So I think everyone know what is solenoid. Solenoid means helical wire. Wire circular, if you move that circle, you'll get helix, yeah. So same thing is your solenoid. Solenoid is actually helical wire. Helical wire having current, we call it as solenoid. And this is how solenoid appears. I think everyone knows, no problem. So this is how solenoid will appear to you. No problem, no problem. Yeah, okay. That means that every solenoid will have some length. Let's assume length of the solenoid to be L, no problem. And in every solenoid, some number of turns will be there. You can count the number of turns. For example, here 1, 2, 3, 4, 5, 6. 6 turns are there, no problem. Yeah, that means that every solenoid will have a total number of turns which we represent by capital N. And this solenoid will also have length, sir. Length we represent as L. Solenoid will have some length. That length we represent as L. And here we can also define number of turns per unit length. We can define small n. Small n means number of turns per unit length. No problem, no problem. Because sometimes in numerical they give number of turns per unit length. Sometimes in numerical they give total turn and length. So both values you must be able to relate. So number of turns. So N is capital N is total number of turns. L is the length of solenoid. And we can also define number of turns per unit length. This is known as number of turns per unit length. No problem. Yeah. Now through this solenoid, if you pass some current I, through this solenoid, if you pass some current I, inside the solenoid some magnetic field will be produced. Inside the solenoid some magnetic field will be produced. Yeah, okay. And value of magnetic field due to solenoid is defined as B will be equal to mu naught Ni. I think everyone knows the value. B will be equal to mu naught Ni. What is a small n, sir? Number of turns per unit length. And if someone give you total number of turns and length, then you can write this also as mu naught N by L into I. So this is the formula that we use for magnetic field due to solenoid. Is it okay? Mu naught Ni, mu naught Ni, mu naught value you know 4 pi into 10 to the power minus 7. N is the number of turns per unit length into I. So if someone gave you total number of turns and length, sir, then we have to use mu naught N by L into I. Is it okay? बोल दो भाई समय हम ले दो त्वरगा. And always all the calculation must be done in SI system. Sometimes they will give you per centimeter or they will give you length in centimeter. You have to convert that length from centimeter to the meter. All the calculation must be done in SI system. Then only your option will match in the NEET exam. I will give you one small question from here. You can try, you can do by yourself, you can write. Just to use this formula, you write it. A solenoid has 100 turns. A solenoid has 100 turns and length of 50 centimeter. A solenoid has 100 turns and length of 50 centimeter. If a current of 2 ampere passes through it, find its magnetic field. If current of 2 ampere passes through it, find its magnetic field. Mu naught value you can put Remanth. And all calculation must be done in SI unit. Centimeter must be converted to meter. Otherwise, option will not match in the NEET exam. Hanudeep is saying correct answer. No problem. Easy question only. Nothing to worry. Yeah, okay. I will simply say, sir, you want magnetic field of solenoid. We already know, sir, total number of turns are given. So, mu naught N by L into I. No problem. Yeah. I think Charita, Hanudeep, check your answer once. Charita correct, Lakshmi correct, no problem. Mu naught value you can put 4 pi into 10 to the power minus 7. Total number of turns given 100. Length given 50 centimeter. So don't use 50 centimeter. You have to convert all the CGS system into SI. Then only your option will match. So 50 centimeter means 50 into 10 to the power minus 2 meter into I. I value is given as 2 ampere. Now 16 pi into 10 to the Tamanna correct, no problem. Pavitra 16 pi will come. How people are getting 8 pi bhai? Bhul gaye kya multiplication bhai? 4 into 2 8, 8 into 2 16. This 10 to the power minus 2 will go in numerator. So it will become 16 pi into 10 to the power minus 5 Tesla. This is the value of magnetic field due to this solenoid. Are bol do bhai. I said, Arey bhai, has 100 turns. If I will say number of turns per unit length is 100, then only you will use it. I said 100 turns, na? I said 100 turns, bhai. And length 50 centimeter. Length I said 50 centimeter. If I have to give you small n, then I will say 100 turns per meter. Or if I say 100 turns per centimeter, so that per centimeter again you have to convert into meter. Bol do bhai, bol do. Easy na? No problem. So maybe you heard wrong, okay. But formula everyone must know how to apply it. Everyone will get the answer. Done? Bol do bhai, bol do. Twarga samayam le do. Same is going on. Are bol do. And some more things I will tell. Just see here. 1-2 more points I will tell here. Dhyan do, just see here. No problem. Given in NCERT, you may have seen in your chapter. What was that chapter? In magnetic dipole, one chapter you may have seen. One more thing. One more point. Just see here. Yeah. Okay. No problem. Magnetism and matter, you may have seen one more thing. Sometimes what happens, if you want, from here you can write B by mu naught. B by mu naught will be equal to Ni. Can you tell me what is this B by mu naught? This is done in magnetism and matter. Maybe you have done or you're not done, so that's why I'm telling. Again, we are revising this part. Can you tell me what is B by mu naught? B equal to mu naught Ni. You can bring mu naught this side, so you'll get B by mu naught. B by mu naught will be Ni. What is B by mu naught? What is B by mu naught? Magnetic intensity H. Sometimes they ask H of solenoid. So H of solenoid will be your Ni. Or you can say H will be equal to N by L into I. This is also given in NCERT. All these points are given in NCERT. What will be magnetic intensity of solenoid? That is small n into I or N by L into I. Bol do bhai. H, magnetic intensity. Generally they ask magnetic field, but sometimes they can ask you what is H of solenoid, magnetic intensity of solenoid. So B by mu naught is defined as H, that is magnetic intensity or intensity of magnetizing field or magnetizing force. No problem. Yeah, okay. And sometimes always remember we use formula mu naught Ni only when inside vacuum is there. For example, someone says, sir, inside the solenoid, if I put one ferromagnetic material, right now vacuum is there, that's why you are using mu naught by. Some say, sir, inside solenoid, if I put some other medium means inside the core. This is known as core of solenoid. Generally not asked, but I'm just giving you idea. If they ask you, in the core of solenoid, if some material is there, some ferromagnetic material is there. So if some other medium is there, some material is there, means other medium is there, your magnetic field will become mu of medium into Ni. And this mu of medium, you know, it will be mu r into mu naught. Or you can say 1 plus xi into mu naught. All these things you have studied in magnetism and matter. Same thing I am using. Generally, they will ask you what is the magnetic field due to solenoid, mu naught Ni or mu naught N by L into I. But if they ask you H, B by mu naught is H, so Ni or N by L into I. Or if some other medium is there, you have to use permeability of that other medium. So mu m will become mu r into mu naught. Mu r, you know, 1 plus xi into mu naught. So this is how we can do. Arey bol do bhai, ho gaya, done. Arey bol do bhai. Twarga samayam ledu, we have to move further. Now we will talk about, so this is how we talk about our fourth application. Once you can sit and you can see all this situation, it's a very easy situation, nothing to worry. Now can you guess what will be our next magnetic field? What can be our next magnetic field? What can be our fifth situation? Any guess? Any guess by fourth situation, solenoid. After solenoid, what we studied? Toroid. Very good. You can write magnetic field of toroid. We talk about magnetic field of toroid. Again, one important part, chinna part, but important part. Questions are continuously asked. Cylindrical wire we'll study after that, Jamir. No problem. Yeah. Magnetic field due to toroid. Acha, what is toroid? Can you tell me what is toroid? Okay, magnetic field of toroid. Solenoid done, sir. Now we'll talk about magnetic field of toroid. What is toroid? Actually, toroid is turned solenoid. Yeah, solenoid, brother. Wow. Okay. No problem. Huh? Which proportion? Arey bhai, you can do from there so that no one will ask you that. Okay, no problem. Huh? Circular, sir. Donut. No problem. Or jangri. Dhyan do. Just say no problem. Actually, this is how toroid means turned solenoid. If you see name are similar, they are brother and sister. So always remember toroid is turned solenoid. For example, toroid is turned solenoid. For example, if you have one solenoid, someone says, sir, I have one solenoid, no problem. Sir, I am having one solenoid, no problem. Yeah. It's not deleted by toroid is there. Pagal ho gaye ho kya? Okay, no problem. Huh? Okay. So toroid means turned solenoid. For example, one solenoid is there. If you hold the both ends of solenoid, dono from both hands, if you hold the two ends of solenoid and if you forcefully join them, your structure will become. You took the both ends of solenoid and you simply join them. If you join them forcefully, you will get a structure like this. You'll get a turned solenoid. This turned solenoid in physics is known as toroid. Same as your jangri, same as your donut, same as your polo chocolate. If you take the two ends of solenoid and if you join them forcefully, it will become toroid. Now dhyan do, be focused. Okay sir, we understood how we generate the toroid, no problem. Acha, once you do this, here one cavity will be created. So first question comes, how much magnetic field will be present in the cavity of toroid? So always remember, in the cavity magnetic field will be 0. In cavity nothing is there. Magnetic field will be only present inside this toroid. In the cavity of toroid, you will never get any magnetic field. Magnetic field will be only present inside the toroid. So sometimes what happens, they give so many data and at the end they ask, what is the magnetic field in the cavity? Students start calculate, no need to calculate. Cavity level, nothing there. That is the meaning of cavity. Cavity means nothing is there. If nothing is there, magnetic field will be also. So in the cavity of toroid, magnetic field will be 0. Now someone said, then what is the magnetic field inside the toroid? If nothing is mentioned, that means they will talk about inside. So always remember, this toroid is coming from solenoid only. So that's why magnetic field due to toroid will be also same value. Toroid will also, outside also 0, no problem, Jabir, okay. No need to, they generally don't ask for outside. Outside everywhere it will be 0, no problem, So, first point, magnetic field in the cavity of toroid, nothing is there, sir. That's why magnetic field in the cavity of toroid will be 0. Then someone says, sir, then what is the magnetic field inside the toroid? Or what is the magnetic field of toroid? Nothing mentioned means they are talking about inside, So inside, since it is coming from solenoid, so that's why due to toroid also, same magnetic field will come, mu naught Ni. Or you can say, sir, B will be mu naught N by L into I. Now someone says, okay, no problem, we understood, sir, same thing. But here if you see, its shape is circular, na bhai. For straight things we can write length L. But for circular, can you tell me what length I should write? Writing length L is not good for circular things. For circular things, we should write length as a circumference, 2 pi r. This is the only difference. Magnetic field due to toroid will become mu naught, sir, N by L. Circle का length कितना होगा, sir? Circle का length, अरे shape circular है ना भाई, circular है ना, so length कितना होगा? Circumference के बराबर होगा और perimeter के बराबर होगा. That is 2 pi r into I. So this is the final result that we use for magnetic field of toroid. Same formula, don't think any new formula. Since its shape is circular, so that's why I have to take length of circle is 2 pi r. Now here one problem comes. ध्यान दो, just see here, no problem. Okay sir, we understood. So shape was circular, that's why you have written length as 2 pi r. But always remember, Jameer, yeah, we are talking about that only. Yeah. Now you will say, sir, that means, sir, okay, 2 pi r. But sir, in toroid, 2 radius will come na bhai. One will be inner radius, one will be outer radius. Now you see, one inner radius will be also there, one outer radius will be also there. So can you tell me which radius I should select there? कौन सा radius लूं? अरे 2 radiuses will be there ना, cavity is there ना, one inner radius, one outer radius. So 2 pi r you said length. So length के लिए कौन सा radius लूं? Inner लूं या outer लूं? Inner लूं या outer लूं? Average radius, भाई पागल हो गए हो क्या? When we cannot decide which radius, then we have to take average radius. Actually, this is your mean radius or average radius. This is not, this is So always remember, radius of toroid you have to take. अरे R1 also there, R2 also there. कौन सा radius ले लूं sir? You have to take mean radius or average radius, and that mean or average radius you can find. You know R1 average, you know how to find. R1 plus manchi plus chadda by 2. This is how we calculate average radius. Is it okay? Outer भी नहीं लोगे, inner भी नहीं लोगे, दोनों का average लोगे. That is the average radius. बोल दो भाई, समझ में आया क्या कौन सा रेडियस लेना है? If they give you inner radius, if they give you outer radius, first calculate mean radius R1 plus R2 by 2. Then you can put in the formula to get the answer. अरे भाई, no problem. So this is how we can talk about. Toroid. I'm giving you time of 2 seconds. See this toroid, then we will move further. We'll start with our next application. क्वेश्चन चाहिए? चलो एक क्वेश्चन कर लो भाई, त्वरगा समय हम ले दूं. Do one question from toroid. एक क्वेश्चन कर लो toroid से भी, no problem. You write. A toroid has, just use this formula, no problem. A toroid has 200 turns. A toroid has 200 turns. And mean radius of a toroid has 200 turns and mean radius of 2 centimeter. A toroid has 200 turns and mean radius of 2 centimeter. A toroid has 200 turns and mean radius of 2 centimeter. If 2 ampere of current passes through it, find its magnetic field. If 2 ampere of current passes through it, find its magnetic field. If they say cavity of the toroid, then directly no calculation, 0. But if they say magnetic field of toroid, means they are talking about inside. Find its magnetic field. Jaldi bhai. Amrut, very good. मेघना पाई का वैल्यू म्यू नॉट का वैल्यू पुट कर दे भाई. हनुदीप वेरी गुड. चैरिता कौन सा कैलकुलेशन किए? पवित्रा सेंटीमीटर को मीटर में कौन कन्वर्ट करेगा भाई? ये बच्चे पागल हो गए. कितने बार बोल चुका हूं, सेंटीमीटर को मीटर में कन्वर्ट कर ले, अभी भी नहीं कर रहे हैं. मैं क्या करूं? अरे पहले फॉर्मूला लिखो. सीम्स टू बी इजी बट पीपल डू मिस्टेक. n by 2 pi r average into I. Now put the value mu naught 4 pi into 10 to the power minus 7. n means total number of turns are 200 by 2 pi r. r कितना दिया हुआ? 2 सेंटीमीटर. उसको मीटर में कन्वर्ट करो भाई. पापा नहीं आएंगे कन्वर्ट करने. I is 2 ampere. So now from here if you solve, so this many people miss this conversion, so that is important. So this will become 2, then these 2 cancel. So I think it will come 4 into 10 to the power minus 3. Kyala Tesla. 4 into 10 to the power minus 3. Meghna is still getting 8 pi. I don't know how she is getting 8 pi. मैं तो पागल हो गया हूं. मेघना, your answer after seeing your answer. Madhunika correct, Lakshmi correct, Ganesh correct, Sanam correct. So this is how we talk about toroid. Rajkumari correct, no problem. I'm giving you time of 2 seconds. Yeah, Sumajara correct, no problem. I'm giving you time of 2 seconds. Once you can see solenoid and toroid, then we'll move towards our sixth application. Sixth and last value. Sixth and last value. Once completed, you can say done, sir. Ha, chamka, no problem. Yeah, once I will say dancer, start saying dancer. Opika ledu, why to have opika sat till need 2024? Opika ledu, no problem, no problem, no problem. Madhu Sudarani, you can see at the end, no problem. Yeah, okay. Now we'll move towards our sixth application. You can write magnetic field due to. Magnetic field due to. Pavitra, that is also correct answer. Correct, bhai. Okay. Okay. Magnetic field due to long cylindrical wire. Magnetic field due to. Then we will study Ampere circuital law cars. Yeah, okay. Magnetic field due to long cylindrical wire. Magnetic field due to long cylindrical wire. Magnetic field due to long cylindrical wire. Acha, wire is solid or hollow? Electrical wires that we use are solid or hollow? Wire that we use are solid or hollow? Huh? Are bol do bhai, wire that we use are solid or hollow? पागल हो गए हो क्या? चरिता तू छोड़ दे भाई. सॉलिड भाई. वायर इज ऑलवेज सॉलिड. पाइप इज हॉलो. हे भगवान, दैट पाइप दैट वी पुट वायर इन द पाइप ना, दोस पाइप्स आर हॉलो. दे आर नॉट, दोस आर पाइप, दोस आर नॉट वायर. Wire, yeah, okay, yeah, that is mass. Okay, no. So always remember, wire is always solid until and unless it is not mentioned. Until and unless it is not mentioned, someone said, that's why I said you previously also, if nothing is given, we are talking about solid. So always remember, if someone says cylindrical wire, means solid only. Or someone said solid cylindrical wire, that also means solid. If they want to ask you hollow, they have to mention separately. For solid wire, no need to mention separate. Simply wire also means solid cylindrical wire. So in bracket, you can write solid. And this solid, mandatorily, they will not mention in the NEET exam. No problem, no problem. Now, dhyan do, be focused. Again, one of the most important part, magnetic field due to long cylindrical wire. Cylindrical wire means solid cylindrical wire. Now, dhyan do. Actually, this is one solved example of NCERT. This is actually no such application is given in NCERT. But this is one solved example of NCERT. So that's why we are talking about questions are asked. Minimum 10 question has been asked previously from a long cylindrical wire. Long cylindrical wire means solid cylindrical wire. So once you can see what are the things which they ask. Yeah. And here they will not ask you value because derivation is lengthy. They will not ask you value. They will ask you simply proportionality. How magnetic field will depend on distance, directly proportional or inversely proportional. Then what will be the nature of graph? So all these things are asked. Value is not important. Proportionality is important. So they have to just see here. No problem. Yeah. So we are going to talk about magnetic field due to long solid cylindrical wire or long cylindrical wire. So this is how we will have a cylindrical wire. No problem. Long cylindrical wire means solid cylindrical wire. Solid cylindrical wire means through its cross-sectional area, current will flow. That's why if you remember, you studied current density, charge per unit A, current I by A. Because current always flows through cross section of the wire. No problem, yeah. And this solid cylindrical wire will also have some radius. Of course, its cylinder, cross section of cylinder is circular, so it will have some radius, no problem. Now here, two places they will ask. What will be its magnetic field outside? What will be magnetic, how magnetic field will depend outside? And how magnetic field will depend inside. So just see here, no problem, yeah, okay. Someone says, no problem, yeah. Someone says, sir, I want magnetic field at a distance, small r from its center, I want magnetic field. At distance small r from the center, I want magnetic field here. Now you tell me if this small r is greater than radius. This point will be located inside the wire or outside the wire. You tell me if small r is, if distance from center is more than radius, point which we are calculating magnetic field is located inside or outside. Although you are done for solid sphere also, hollow sphere also. This is outside, yeah. Sir, r greater. If distance from center is more than radius, you are talking about outside. So always remember, outside magnetic field due to long cylindrical wire will come inversely proportional to distance. Inversely proportional to distance, no problem. Outside inversely proportional to distance. Inversely proportional means as the distance will increase, magnetic field will decrease. Means magnetic field outside decreases hyperbolically. You can see inversely proportional means magnetic field outside will decrease hyperbolically. No problem. Hyperbolically. No problem. Yeah, okay. And second point they will ask, if distance from center is less than radius. If the distance where you are calculating magnetic field is less than radius, means we are talking about inside, and inside magnetic field will come directly proportional to R. Directly proportional means inside magnet, as you increase the distance from center, inside magnetic field will increase linearly. And if you draw the graph inside graph will be straight line. Outside graph will be hyperbola. Inside graph will be straight line. That means you'll get the same graph of electric field due to solid sphere. B and R graph will also come same as your solid sphere. Inside straight line, one point will come R equal to capital R. Before this inside, after this outside, this is your surface. So inside straight line. Then inside straight line, outside hyperbola. अरे बोल दो भाई. Inside directly proportional to R, outside inversely proportional to R. No problem. So that's why graph will come like that. Same graph of solid sphere, if you remember. If you want exact value also I can write, no problem, but value will not be asked because derivation is very complicated. If you want I can write the value also. Outside value of magnetic field will come mu naught I by 2 pi distance R. Inside magnetic field value will come if you wish. That's why I'm writing, otherwise not required. Okay, we should not complicate the things. This I am complicating by writing the value, but okay, no problem. You can write, no problem. Mu naught I by 2 pi R square into R. Same as your solid sphere, if you remember. Something like that is coming. Bol do bhai, twarga. Is it okay? One more point is there. That's why I'm waiting. One conceptual, one important question is asked. जल्दी बोलो भाई. No problem, no problem, no problem. Okay, okay. No need to remember those values. Proportionality is enough. No problem. Yeah. Now, one last thing which is important here. One last thing which is important here. ध्यान दो, ध्यान दो, ध्यान दो, ध्यान दो. Be focused, be focused, be focused. Yeah. अच्छा, if you observe this graph now, you will realize for example, if I say here magnetic field is B naught. Now you will find that for 2, here also you can see, here also magnetic field will be same, here also magnetic field will. Dhyan do what I'm trying to tell. One numerical, one easy numerical is asked from here. Ek baar graph ko dekho. Once you see the graph, you realize that for 2 different location, one less than R, magnetic field B naught, one more than R, magnetic field B naught. So always remember, for 2 different locations you will get same magnetic field, but one point will be situated in, here also magnetic field is B naught na bhai, here also magnetic field is B naught na, but this point is situated less than R, this point is situated more than R. So always remember, for 2 points magnetic field will be equal. One point will be situated lopala, other point will be situated beta. Now you will say, sir, then how these points will be situated? These points will be situated in a pattern. For example, inside point will be R by 2. Then outside point will become 2R. Because relation is reversed. If inside point is R by 2, outside point will become 2R. For example, if inside point is R by 3, outside point will become 3R. For example, inside point is R by 4, outside point will be have 4R. And always remember, for every pair of these points, magnetic field will be equal. B1 will be equal to B2. So they generally ask what is the ratio of magnetic field at R by 2 and 2R. That ratio will come 1:1. Are bol do bhai. This is a pair of points you saw there. For 2 points, same magnetic field will come. One point will be located lopala, other point will be located beta. And how they will be located, I told you. If one is at R by 2, other will be 2R. If one is R by 3, other will be 3R. For these pairs, field will be equal. So their ratio of field will always come 1:1. It's a lucky question. Directly they can ask you. अरे बोल दे भाई, त्वरगा సమయం లేదు. ओके, इतना बड़ा ग्राफ देख के डर तो नहीं गए. आई विल मिनिमाइज इट. अरे जल्दी भाई, समय ले दू. So for these pairs, field will be equal. One inside, other outside. Now one more thing I can tell you. Okay sir, we understood, we got all this proportionality. But sometimes in the exam, if someone says you, use this only when it is mentioned clearly. Hollow cylinder, if I have a hollow cylinder or hollow pipe. So if it is hollow, you know, inside magnetic, this is not given in NCERT, only this is given. So that's why I said you, any question comes, use this. But if someone says, by chance someone says, sir, I have a hollow cylindrical wire, hollow word there, or hollow pipe, then you know now, inside magnetic field will be 0. Inside, same as your hollow sphere. Inside magnetic field 0. Outside, same relation. Inversely proportional to R. So here also, if you draw the graph will come same as your hollow sphere. Hollow sphere ka graph aayega. Tak, 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 tak. Woo! Same as hollow sphere. Jaldi bhai. But use this only when you are 100% sure. मीन्स एग्जाम में दिख गया हॉलो सिलेंडर, तभी इसको यूज करोगे. उसके अलावा कुछ और दिखा तो उसको यूज करोगे। इज इट ओके बोल दो भाई, त्वरगा समय हम ले दूं। Because when they give you this question, both graph will be in option. तो थोड़ा ध्यान से, गलती मत कर देना। So this is how we talk about all the applications which we have. Now we will talk about one more law. One more law. Actually, we have covered those laws in this application, but we will talk about that law. You can write Ampere circuital law. Ampere circuital law. Last law of this chapter, Ampere circuital law. Ampere circuital law. And you can write a statement of this law. Ampere circuital law, and you can write a statement. No problem. Yeah. You can write a statement. You can write line integration of magnetic field, line integration of magnetic field, line integration of magnetic field along a closed loop, line integration of magnetic field along a closed loop will be equal to line integration of magnetic field along the closed loop will be equal to mu naught times of net current. Line integration of magnetic field along the closed loop will be equal to mu naught times of net current enclosed by the loop. Line integration of magnetic field along a closed loop will be equal to mu naught times of net current will be equal to mu naught times of net current enclosed by the loop. Enclosed by the loop. And this is the equation that we have from our Ampere circuital law. Now you say, then sir, what question will come? They can ask you which of the following equation is a Ampere circuital law. So dhyan do, just see, no problem. So this is what Ampere circuital law says. Sir, they are saying line integration of magnetic field. Line means length. So if you integrate magnetic field along the length, this is the statement. Line integration of magnetic field means that we have to integrate magnetic field, but we have to integrate the magnetic field on the line. Line means we have to integrate magnetic field on the length. So that's why we say integration B vector dot dl vector. You can see I am integrating magnetic field over the length. Line integration of magnetic field along a closed loop. Closed loop we represent here will be equal to mu naught times of net current. Net current तो कौन सा current लूँ सर? Only current enclosed in the loop. Enclosed in the loop, just like your Gauss law. It is similar to Gauss law of electrostatic. Ampere circuital law is similar to Gauss law of electrostatic. So line integration of magnetic field will be equal to mu naught times of net current enclosed in the loop. No problem. Dhyan do, be focused. Means what I'm trying to tell. For example, assume I have one closed loop. Assume I'm having one closed loop. Closed loop means any shape of loop. I'm having one closed loop. Now, two types of current will be in the loop na bhai. Some current will be coming outward. Some wire will have current outward. Some wire will have current inward. Always remember, outward current we take positive. You can take any one positive, other will become negative. But generally, Outward current we take positive. Inward current we take negative. No problem. Some current may be outside also. Let's assume here current I3 is there. Let's assume here current I4 is there. So what Ampere circuit law says? If you move on this loop, if you make a closed loop, for example, if you start from here and if you come back here and if you integrate the magnetic field on the loop, that integration of magnetic field along the closed loop will be equal to mu naught times of net current. Always remember, net current means the two types of current will come. Some current will be outward, some current will be inward. Conventionally we take outward positive, inward negative, so net current will become I1 minus I2. This is also there plus I3. That is also there outward plus I4. Is it okay? Is it okay? Or some mistake is there? Or some mistake is there? Jaldi bhai, samay hum le do. We have to talk about one more concept. Is it correct or some mistake I have done? अरे जल्दी बता दो. Mistake is there. Only lopala current, that is the meaning of only enclosed. Enclosed means this I3 and I4 will not come bhai. Sir, what you are doing? You are writing enclosed. Enclosed means we have to see only the current which is present in the loop. Baita current we will not take. We have to take only the current present in the loop, same as your Gauss law. And always remember here this magnetic field is due to all current. If you remember there also I told you this magnetic field is due to all current, lopala as well as baita, inside as well as outside. But this is only due to inside, only inside current. Is it okay? Bol do bhai. Ha, we have to take only current present in the loop. Current enclosed by the loop. I'm giving you time of 2 seconds. See all this situation. We'll move further. आगे बढ़ेंगे. They will give you I1. For example, I1 is 4 ampere, I2 is 2 ampere, and they will ask you what is the value of integration B dot dl. So that will become mu naught times of 4 minus 2. It will become 2 mu naught. That is how question will come. No problem, no problem. What else we have to start? Any guess? We have completed applications. We already completed. Actually, solenoid, toroid, and long wire, cylindrical wire are actually application of Ampere circuit law. But we have covered them. No problem. Yeah. What else? क्या बचा है यहाँ पे? जल्दी बता दो. Important part. Galvanometer we'll do in the last class. One more thing is left here. You can write. Come on. Moving coil galvanometer, tangent is not there in the NEET syllabus, bhai. It is not from last 10 years, tangent galvanometer, not removed now. It's never there, yeah. MCG we will start in the next class. Before that, one important topic is left. You write force between parallel wires. Force between parallel wires. Force between parallel wires. Force between parallel wires. Force between, again important part, NCERT part, important part. So many times question has been asked. Small topic but very important topic. Yeah. Okay, no problem. No. Yeah, correct. Okay, Akash will talk about that. No problem. Yeah. Force between parallel wires. Achha, if two wires are, achha, which force we are talking about? Which force? Sir, you are talking about force between parallel wire. Are you talking about gravitational force? Are you talking about electrostatic force? Which force actually we are talking here? So we are saying force between parallel wire. Which force actually we are talking? कौन से force के बारे में बात कर रहे हैं? जल्दी बता दो. कौन से force के बारे में? That will tell us the value. कौन से फोर्स के बारे में? बिल फोर्स के बारे में. बिल इन ब्रैकेट यू राइट F इक्वल टू बिल. In bracket F equal to bill. I am not talking about electrostatic. I am not talking about gravitation. I am not talking about frictional force. I am talking about magnetic force. And magnetic force, you know, if current is there, magnetic force will be bill. Magnetic force. Yeah. Okay. We will use that result. No problem. No problem. Yeah. Okay. Now always remember. The time is less. Develop understanding. No problem. Yeah. Always remember. Whenever you have parallel wires now, two possibility will be there. Either both wires will have current in the same direction, I1 and I2. This we call as parallel currents. Whenever you have two parallel wires, two possibilities will be there. Either they will have current in the same direction, or they will have current in. Wire is parallel both cases, but current not mandatory to be parallel. Current can be in the same direction, current can be in opposite direction. So when we have current in the same direction, we call it as parallel current, and when we have current in opposite direction, we call it as anti-parallel current. And this is a very famous statement here. I will write that statement, no problem. Always remember, parallel currents always attract each other. If two wires carry current if two parallel wires carry current in the same direction, they will attract each other. And if they have current in opposite direction, these two parallel wires will always repel each other. Is it okay? Slowly I will tell why it is attracting, why it is repelling, but statement is also important. Parallel current, statement of NCERT, written in bold letters. Parallel currents attract, anti-parallel currents repel. Parallel currents attract, anti-parallel currents repel. Parallel currents attract, anti-parallel currents repel. Means if two wires will carry current in the same direction, they will attract each other. If two wires will carry current in the opposite direction, they will repel each other. Wires are parallel. We are not talking about wires. We are talking about current. This is not, this is anti-parallel, not anti-current. This is anti-parallel. Anti-parallel current repel each other. Is it okay? एक बार बोल दो भाई. No problem. We'll talk about that. No problem. How it will attract, repel, we can do. No problem. अरे बोल दो भाई. Parallel currents attract each other. Is this statement clear? Parallel currents attract each other. Anti-parallel currents repel each other. अरे बोल दो भाई. बोल दो त्वरगा. Parallel currents attract each other. Anti-parallel currents repel each other. अरे बोलो. Now someone said, okay sir, parallel currents will attract each other, anti-parallel currents will repel each other, but tell us the force now. Sir, force तो बताओ ना. What is the force of attraction or repulsion? You are saying attract करेगा, तो attract करेगा तो कुछ force होगा ना भाई. Sir, tell us force. Sir, here these two wires are there. These two wires will attract each other. These two wires will repel each other. So there must be some force of attraction now. There must be some force of repulsion now. Tell me value of that force. So see here how to find the value of force of attraction or repulsion between two parallel wires. So for example, assume separation between the wires to be D. Now, if you look at, someone says, so find the force on wire 2. Same force will act on wire 1, also action-reaction pair. Now someone says, sir, tell me how much force wire 2 will experience. You know wire 2, you can find magnetic force, you know, force will be, sir, bill. Now I will simply say, now you tell me on wire 2, who will produce magnetic field? On wire 2, who will produce magnetic field? Around wire 2, you are seeing wire 2. Actually, wire 2 is in the magnetic field of wire 1. On wire 2, on wire 2, wire 1 will produce magnetic field. You are seeing wire 2, but actually wire 2 is in the magnetic field of wire 1. So that's why we say, sir, B will be produced by wire 1. That is, sir, B1. You are calculating force on wire 2. So I2 into L. Now B1 value you can find. B1 is produced by wire 1 now. So B1 value you can write. Sir, I know how much magnetic field this I1 will produce here. That is mu naught I1 by 2 pi d. Magnetic field due to long straight wire into I2 into L. This is the value of force. If you arrange it, this final value of force will come. If you arrange it, this final value of force will start coming as F will become mu naught I1 I2 by 2 pi d into L. This is the force of attraction or repulsion between the two wires. But many times they ask, what is the force per unit length? So you can bring length here. Force per unit length will become mu naught I1 I2 by 2 pi d. This is the force per unit length between the two wires. Yeah, Zamir, correct. No problem. अरे कुछ समझ में आया? If you calculate on wire 1, if you calculate the force on wire 1 now, then here B2 will come, here I2 will come, here I1 will come, but value will remain same because you are product of both of them. अरे एक बार बोलो, एक बार देखो, समझ से ओके सर यू सेड फोर्स ऑन वायर 2, मैं तो वायर 1 पे कैलकुलेट करूंगा, तो करो वायर 1 कैलकुलेट करोगे तो here who will produce field? Wire 2. So mu naught I2 by 2 pi d into I1 into L. Again now here you will get I2 into I1. That is the same I1 into I2. So that's why same force will act. Done. अरे बोल दो भाई, they will give you I1, I2, all these values they will give. Dump there, you will get always answer. समय हम ले दूं. अरे कुछ बोल दो हाँ या ना, समझे क्या? And Y attraction repulsion you can check using left hand rule by seeing the direction of your magnetic field. So this is how we have talked about. More situation from here we'll be talking in our next class. For today we'll be ending here only. Tata, bye bye, take care, study well, bye.